I want to take this privilege to welcome you all to my channel. The name of my channel is Professor Dr. YT. So it is a platform to help us students to share ideas on our various topics. So in this channel, I used to solve questions on differential equations and perhaps mechanical behavior of materials or transport systems. By mostly we are generalized on differential equation. So please, I want you to help me to promote my YouTube channel, like, share, comment. If there is any mistake, please let me know so that we all keep the fire burning. And I hope, after all, your life will never be the same. You will learn something, and me too, I will learn something from you guys. Okay, so today the question on board is to say we should solve the ordinary differential equation, that's the ODE. So we have various ways of approaching such questions. So we ask ourselves, this equation that has been given, is it separable? Is it Bernoulli? Is it a Riccati? Are we going to use Riccati equations to solve? Are we going to make a substitution? So we ask ourselves all this. But then, we all know that this equation y prime plus 4 over xy is equal to x exponent 4. This is the question that we have been given. So I always prefer you getting the understanding or the concept. So upon the concept, then we derive this formula. So not necessarily using the formula, but then we have to understand the concept behind. So it's the concept behind that made us use this formula, but not applying it for sake. Okay, so this equation is in the form y prime plus 4 p of xy equals q of x. So I can compare this equation. So this is a linear equation. This is the form for a linear equation. So I can boldly say this is a linear equation. It's a linear differential equation in a sense that for a particular differential equation to satisfy a linearity, then there shouldn't be the transcendental functions written in terms of the dependent variable. So here my dependent variable is y, because remember y prime is dy dx. So my dependent variable is y and my independent variable is x. But there's no transcendental functions. When I say transcendental function, that's the logarithm, the exponential, and the trig functions. There's no these transcendental functions written in terms of the dependent variable, which is y. So I can boldly say this is a linear equation. 2, it is a linear differential equation because the higher order is 1. And also, I can boldly say it is a linear differential equation because the derivative is not much, there is no product of the derivative and the dependent variable. Okay, so this is a function 4 over x. This is not a derivative. So I can boldly say this is a linear equation. So all the conditions is satisfied. So I can proceed. So by comparing, I know that my coefficient of y is 4 over x. So my p of x will be 4 over x. Then my q of x is equal to x exponent 4. So in this case, what we are intending to do is that we find the integrating factor. So the integrating factor is equal to e exponent integral of p of x dx. So my mu, that is the integral factor, is equal to, now I know my p of x to be 4 over x. So I'll just make a substitution, dx. So from this place, my 4 is constant, so my 4 can come out, leaving 1 over x. So when I multiply 4 by 1 over x, I'm getting 4 over x. It's the same thing. Nothing has done to the equation. So from this place, I will integrate the 1 over x. You know that when I integrate 1 over x, it's a function and a derivative. The denominator is x. That's a function. And you know that when you differentiate the x, we are getting 1. So it's a function and a derivative. So we are going to get ln x. So e exponent, your constant for ln x. And we don't leave it like this. It's a logarithmic function. So whenever you have a constant in front, the constant can come as an exponent of the any value here. So the value here is x. So the 4 will come and be the exponent of the x. So I know that the subscript of ln is e. So my ln e will cancel the e. This is a natural log. This is a natural log. So the natural log with an exponent e will cancel this. So leaving x exponent 4. So this is my integrating factor. Mu is equal to x exponent 4. Then after that, the linear equation will take this general equation. Linear differential equation will take this general equation. Y is equal to 1 over the mu multiplying the integral of q of x times my mu dx plus c. So by substitution, I have already found my mu. I know my q of x. I know my mu, and this is the dx. So that's the derivative. Okay, so I just make a substitution. So I'm going to get 1 over the mu, which is x exponent 4, multiplying the integral of the q of x, and we found the q of x to be x exponent 4. From here, our q of x was x exponent 4. So we make a substitution here, x exponent 4. Then my integral factor to times the mu, that's the integral factor, and the integral factor to we had x exponent 4 times dx plus c. So further on, my y is equal to 1 over x exponent 4 multiplying integral of, so this x exponent 4 is multiplying x exponent 4, so we take 1, it's the same base, you add their exponent, so I'm going to get x exponent 8 dx plus c. So further on, we are getting 1 over x exponent 4 multiplying. I know that when I am about to integrate x exponent 8 or integrate x exponent 8, you just add 1 to the power. So when add 1 to 8, you are going to get 9. Then you divide by the result, which is 9, then plus c. So after that, I am done with the integrating aspect. So I will just multiply the whole of this equation through by 1 over x exponent 4. So upon multiplying the whole of this equation by 1 over x exponent 4, my x exponent 4 will go into x exponent 9, x exponent 5. So I'm going to get x exponent 5 divided by 9 plus 1 over x exponent 4 multiplying c. So I'm going to get c over x exponent 4. So for us to get a nice presentation, I can say my y is equal to 1 over 9 x exponent 5, and this c over x exponent 4 can be written as c x exponent negative 4. Thank you very much.